Dear friends, today we will discuss the sinkhole and doline structures. A sinkhole is a depression or hole in the ground caused by some form of collapse of the surface layer. Some are caused by karst processes, for example, the chemical dissolution of carbonate rocks or suffocation processes. Sinkhole may vary in size from 1 to 600 meters or 3.3 to 2000 feet, both in diameter and depth, and vary in form from soil-lined bowels to bedrock-edged chasms. Sinkhole may be formed gradually or suddenly and are found worldwide. Sinkholes are formed when water flowing underground has dissolved rock, mostly limestones and sometimes clay, below the surface, leading to the formation of underground voids when the surface layer can no longer take the weight of whatever that's above. It collapses into the void, forming sinkholes. These sinkhole structures can be dramatic because the surface land usually stays intact until there is not enough support. Then a sudden collapse of the land surface can occur. Sinkhole is a topographic depression formed when underlying limestone bedrock is dissolved by groundwater. It is considered the most fundamental structure of karst topography. Sinkhole varies greatly in areas and depth and may be very large. There are two main varieties, one caused by the collapse of the roof of a cavern, the other by the gradual dissolving of rock under soil mantle. Collapsed sinkhole generally has steep rock sides and may receive streams that then flow underground. The soil-mantled sinkhole is generally shallower than the collapsed sinkhole and receives local drainage. It may become clogged with the clay and hold a small lake. The different terms for sinkhole often used interchangeably are sinkhole, swallet, swallow hole, or doline structures. The following modules are covered in this chapter, which will explain the sinkholes, doline structures in detail. Formation of sinkholes can be either natural or artificial. Both of these processes are described below in brief. Number one is the natural processes. Sinkholes may capture surface drainage from running or standing water, but may also form in high and dry places in specific locations. The formation of sinkhole involves natural processes of erosion and gradual removal of slightly soluble bedrock such as limestones by percolating water. The collapse of a cave roof or a lowering of the water table or through the process of suffocation. For example, groundwater may dissolve the carbonate cement holding the sandstone particles together and then carry away the lax particles, gradually forming a void. Occasionally, a sinkhole may exhibit a visible opening into the cave. Sinkholes are common where the rock below the land surface is a limestone or other carbonate rocks, salt beds, or in other rocks such as gypsum that can be dissolved naturally by circulating groundwater. Sinkholes also occur in sandstones and quartzites terrains. As the rock dissolves, spaces and caverns develop underground. These sinkholes can be dramatic because the surface land usually stays intact until there is not enough support. Then a sudden collapse of the land surface can occur. Number two, artificial processes. Sinkholes also form from human activities such as the rare collapse of abandoned mines and salt cavern storage in salt domes. More commonly, sinkholes occur in urban areas due to water main breakers or a sewer collapse when old pipes give away. They can also occur from the overpumping and extraction of groundwater and subsurface fluids. Sinkholes can also form when natural water drainage patterns are changed and new water diversion systems are developed. Some sinkholes form when the land surface is changed, such as when industrial and runoff storage ponds are created. The substantial weight of the new material can trigger an underground collapse of the supporting material, thus causing a sinkhole occurrence. Sinkholes are frequently linked with the karst landscapes. In such regions, they may hundreds or even thousands of sinkholes in a small area, so that the surface as seen from the air looks pock-marked and there are no surface streams because all drainage occurs subsurface. Examples of karst landscapes dotted with numerous enormous sinkholes are the Cameroon Mountains, Laos, and Mamo Plateau, Papua New Guinea. The largest known sinkholes formed in sandstone are Sima, Humboldt, and Sima Martel in Venezuela. The sinkholes formed in Andaman and Nicobar are probably due to the tsunami. Some sinkholes form in thick layers of homogeneous limestones. Their formation is facilitated by high groundwater flow, often caused by rainfall. Such rainfall causes formation of the giant sinkhole on the contact of the limestone and insoluble rock below it. Powerful underground rivers may form, creating large underground voids. In such conditions, the largest known sinkhole of the world have formed, like the 662 meters or 2,172 feet deep Xiaozhai Tiakeng, Chongqing, China, has a giant Soatanos in Querétaro and San Luis Potosi slates in Mexico and others. Unusual processes have formed enormous sinkholes in Sistema Zacation and Tamaulipas, Mexico, where more than 20 sinkhole doline structures. Other karst formations have been shaped by volcanically heated acidic groundwater. This has produced not only the formation of the deepest water-filled sinkholes in the world, Zacation, but also unique processes of the travertine sedimentation in upper parts of the sinkholes, leading to sealing of these sinkholes with travertine lids. Sinkholes can be formed in retention ponds from large amount of rain. Human users of sinkholes sinkholes have been used for centuries as disposal sites for various forms of waste. A consequence of this is the pollution of groundwater resources with serious health implications in such areas. The Maya civilization sometimes used sinkhole in the Yucatan Peninsula, known as cenotes, as places to deposit precious items and human sacrifices. When sinkholes are very deep or connected to caves, they may offer challenges for experienced cavers, or when water-filled diverse sinkholes that form a coral reef and islands that collapse to enormous depths are known as blue holes and often become popular diving spots. The overview of doline structures. The doline structure is the most representative landform of the karst surface. The names derives from the word dolina, a Slav term indicating any depression in the topographical surface. The use of the sinkhole as a synonym for doline structures has also created some ambiguity, because sinkhole is mostly applied in the sense of collapsed sinkhole or of cover sinkhole. From the detailed studies of the doline structure of different karst areas, it is possible to infer that the structures and genesis of this form may be complex. The most correct way to define a doline structure is to add an adjective indicating a peculiar attribute. The most significant attributes are those linked to both the morphogenetical mechanism and the hydrological structure. On the basis of these attributes, it is possible to distinguish several categories and types of the doline structures. Most importantly, to understand a doline structure, it is necessary to be able to reconstruct its history, even if that may be complex, as some doline structures formed by specific processes may later further evolve through different processes. Now let us come to the doline structure. The most representative karst form, the doline structure, is surely the most common, typically and representative landform of the karst surfaces. In the international scientific literature, the terms doline structure and the sinkholes are both utilized in a very wide sense to indicate medium-sized closed depressions, normally not holding water. In karst areas anyway, while the word doline structure is used mostly in Europe with a main morphographic significance, the term sinkhole is utilized mainly in North America with a predominantly morphogenetic meaning. The mental picture of the word doline structure is the subcircular bowel or funnel-like depressions, while that of the sinkhole is a form which has originated through a gradual or sudden lowering of a portion of the topographical surface. In engineering geology, a sinkhole is a steep side closed depression resulting from a sudden collapse downward of the hard rock or of the soft material on the surface. Now let us come to the basis for classification of doline structures. Doline structures are classified from different points of view. For example, number one, a form referred to an object, bowel, tunnel, pit, or to geometrical shape like hemispheric, conical, cylindrical, or to the plan form, that is polygonal, star-shaped, irregular, etc. Number two is size, that is small, medium, large, genesis by accelerated corrosion, by collapse, etc. Next is the hydrological structure, then functionality, lithological and tectonics. Form and size are not significant to characterize the karst depressions and to distinguish them from other closed depressions in different geomorphological environments, but genesis allows the distinction between the main categories of doline structures. It covers, number one, normal doline structures or accelerated corrosions doline structures. Next is collapsed doline structures, then subsidence doline structures, followed by cover doline structures, intersection doline structures, anthropogenic doline structures, etc. Under normal solution, doline structures are distinguished on the following basis: drawdown doline structures, point recharges doline structures, inception doline structure, underprinting doline structures. Between these types, it is possible to recognize subtypes also. For example, it is possible to distinguish very active doline structures from inactive or relic doline structures, chalk type doline structures from massive limestones type doline structures, fault line doline structures from doline structures developed along not displaced fractures, inception doline structures determined by Cherty lenses from inception doline structures determined by the contact of different types of limestones, etc., found in its location and development induced by the structure, topography and hydrogeological behavior of an underlying insoluble buried rock such as weathered and fractured granite below a karstified or karstifiable rock. Next comes the category of collapsed doline structures. It comprehends many forms which are different in type and size of the originate from the collapse of the roof of a cave. Amongst these, there are so-called the karst windows, wide openings between the subterranean world and the outside environment. The subsidence doline structures are closed depressions which originate from the setting down of a surface area of an insoluble rock such as sandstones, following the mass wasting by solution of an underlying soluble rock. The cover doline structures, also called as alluvial doline structures, form as a consequence of the absorption of unconsolidated caustic clastic sediments inside solution cavities which developed in an underlying soluble rock. The intersection doline structures forms following the intersection of the empty or filled caves by the topographical surface and evolves by the weathering and hydrological processes triggered by such an event. From the perspective of the speleologist, the forms may be called as unroofed caves or roofless caves. Doline structures distinguished on the basis of the lithology include salt doline structures, gypsum doline structures, limestone doline structures, dolostone, lithological contact doline structures. For example, some doline structures developed at the contact point between a limestone and a not soluble rock such as basalt. In some peculiar geological and climatic environments, it is also possible to find doline structures in a very low soluble rock such as quartzitic sandstones. The doline structures may be also distinguished on the basis of the climatic environment where they form. So there are tropical doline structures with a star or polygonal plant shape and middle latitude doline structures mostly with a circular plant shape. Peculiar type of doline structures are the cenotes or water table doline structures, which are typical of some tropical areas, and the blue holes or submarine doline structures. If the distinction is based on the closed shape and or on the functionality of the form, some anthropic and anthropogenic forms may also be considered as doline structures. Worth noting amongst these are the bomb craters and some quarries. Some old quarries are now also evolving as doline structures. Between the anthropogenic doline structures, many cover doline structures are triggered both by the lowering of the water table connected with the exploration of the karst aquifers and by mining activities. A relative uncommon category of doline structures is represented by seismic doline structures. Among some fault activated during recent earthquakes, it is possible to observe funnel-like doline structures originating as a result of seismic movements which, when they developed in soluble rocks, evolved later as true karst doline structures. Problems of nomenclature while classification. If there are so many criteria in this definition of a doline structure, it is a problem to establish what is the priority or most correct way to define the form. If all the criteria are considered, one should prepare a special database to be compiled as an identity card for each doline structures. Not only the morphometrical data is to be inserted into this database, but also the structure of the complex landforms, the category, the type, the hosting rock, and the climatic environment, etc. Doline structures developed by a variety of methods like collapse, suffocation, or solution. Collapsed doline structures are formed when the underlying cave passage collapses, forming a depression on the surface above. These doline structures are actually quite rare, as caves are generally quite stable. Most doline structures are formed by the process of suffocation. This is where loose unconsolidated material, including soil, head loess, and clay overlies fissures and joints in the underlying limestone, and material is washed into these fissures and into the caves beneath. Suffocation doline structures tend to develop gradually over months or years as the covering sediments slump into open fissures in the underlying limestones, creating a void which migrates down towards the surface, eventually creating a sinkhole. Solution doline structures are formed by the uneven dissolution of the underlying limestones, creating a broad saucer-like sinkholes. Others occur where a stream sinks underground, creating a blind valley. Although a natural process, the formation of doline structures is often accelerated or triggered by human actions. Broken and land drainages, water mains, and sewerage pipes, increased rainfall, storm events, modified drainage, and diverted surfaces water can help wash sediments into underlying limestones, causing subsidence. There have been many well-documented occurrences of sinkholes, doline structures forming beneath broken water mains, unlined storm water culverts, and leaking swimming pools. Natural sinkhole, as opposed to a man-made tunnel or cave collapses, occur when acidic rainwater seeps down through the surface soil and sediment, eventually reaching a soluble bedrock such as sandstone, chalk, salt, or gypsum, or a carbonate rock such as limestone beneath. In a process that can last hundreds, sometimes thousands of years, the water gradually dissolves the small parts of the rock, enlarging its natural fissures and joints and creating cavities beneath. As the process continues, the loose unconsolidated soil and sand above is gradually washed into these cracks and voids. Depending on how thick and strong that top layer is, sand will not last long, clay can hold out for millennia, and how close to the surface the void beneath is, the land may be able to sustain its own weight and that of whatever we build on the top of it. But as the holes grow, there will come a day when the surface layer will simply give away. The resulting depression characterizes what is known as karst landscape, in which hundreds or even thousands of relatively small sinkholes form across an area that, seen from the air, can appear almost pockmarked, since around 10% of the world's surface is made up of karst topographies. Sinkholes are far from uncommon around the world. This process that produces sinkholes has created such striking natural features where the underlying limestone layer is thick and rainfall heavy. Vast underground caverns and subterranean rivers have produced sinkholes of dimensions that look positively insignificant, what finally triggers a collapse. The most common factors is changing groundwater levels or sudden increase in surface water. During long periods of drought, groundwater levels will fall, meaning cavities that were once supported by the water they were filled with may become weaker. Water pumping or factories or farms can have similar effect. Conversely, a sudden heavy downfall can add dramatically to the weight of the surface layers of soil and clay, making it too heavy for the cave beneath to bear. Sometimes the trigger can be man-made. In chalky West Sussex, the southern England, in 1985, a burst water main caused an alarming rash of small 1 meter to 4 meter wide sinkholes to appear in the village of Fontwell. How can you detect a developing sinkhole? Maps of the country help to locate rock types that may be affected by a sinkhole. It also keeps up to date the National Karst database recording visible sinkhole springs, and using all the manner of modern technologies, an awful lot of data can be avoided, from rock types to slope angles, covering materials and drainage, and basically zones the country into data sets that can be used by property developers, local councils, the construction industry, insurers, and the like. At the most basic level, people in a sinkhole-prone zone are best advised simply to look around them at the adjacent land and buildings. Telltale signs may include sagging trees, fence posts, doors or windows that no longer close properly, and rainwater collecting at unlikely places. Local names give to sinkholes worldwide. Large and visually unusual sinkholes have been well known to local people since ancient times. Nowadays, sinkholes are grouped and named in site-specific or generic names. Some examples of such names are listed below, including black holes. This term refers to a group of unique round water-filled pits in the Bahamas. These formations seem to be dissolved in a carbonate mud from above by the seawater. The dark color of the water is caused by a layer of phototrophic microorganisms concentrated in a dense purple colored layer of 15 to 20 meters or 49 to 66 feet depth. This layer swallows the light. Metabolism in the layer of microorganisms causes heating of the water, the only known case in the natural world where microorganisms create significant thermal effect. One of them is the black hole of the Andros. This name was initially given to the deep underwater sinkholes of the Bahamas, but is often used for any deep water filled pits formed in carbonate rocks. The name originates from the deep blue color of the water in these sinkholes, which is created by the high clarity of the water and the great depth of the sinkhole. Only the deep blue color of the visible spectrum can penetrate such depths and return after reflection. Next is the C notes. This refers to the characteristic water-filled sinkholes in the Yucatan Peninsula, Belize, and some other regions. Many cenotes have formed in limestones deposited in shallow seas created by the Chicxulub meteorites impact. Next is the Sotanos. This name given to several giant pits in several states of Mexico. Then is the Tiacangs. These are the extreme large sinkhole, typically deeper and wider than 250 meters or 820 feet, with most vertical walls, most often created by the collapse of underground caverns. The term means sky hole in Chinese. Many of the largest type of the sinkhole are located in China. Next is the Tomo. This term is used in New Zealand karst country to describe potholes. Now let us summarize the entire discussion. In this chapter we have learned about sinkholes. We know that sinkhole is a topographic depression formed when underlying limestone bedrock is dissolved by groundwater. It is considered the most fundamental structure of the karst topography. Sinkhole varies greatly in area and depth and may be very large. Despite the frequency of sinkhole linked fatalities are rare, catastrophic sinkholes gives you some warning over the course of hours, since extreme of the sinkholes affecting weather, long periods of droughts followed by spells of unusually heavy and persistent rain are widely predicted to become more frequent as Earth's climate changes, and one would certainly expect there to be more sinkholes in future. I hope you might have enjoyed the text. Thank you very much.